Okay, so in this video, I'm going to go over some basics of construction drawings. I'm not going to go over the whole thing here. This is just with the intent that you can find out what the wall construction is made of in a specific room. Okay, so this is the G wing of the stand canvas. I'm going to zoom in a little bit so you can see better. This is the front page. You can see the architect, contact information, the name of the building, and so forth. Um, and so one thing that's really important to point out because it's going to help us navigate this process is down here we have the page number. So this is A001, and then we have A002, and so on. So that's really important. So let's kind of get our bearings here. So this is the G wing. You can see the outlines here with that sort of funky, the walls that are not 90-degree angle. This is the F wing over here. This is the D wing, right? So this is the hallway. Here's the gym up here. There's your hallway, and then the F wing here, hallway. This is the courtyard in front of the G wing, and then you can see here those glass double doors that swing outward toward the courtyard. Okay, so you can kind of see where we are here. I'll let you sort of figure out where the classroom is. But let's look at the detail here. This page will be very helpful. So this is A100. Let's zoom in so we can see as far as we can go. So let's say I want to figure out what the mechanical room wall is made of. Okay, so the different components of the mechanical room wall. So here's the mechanical room, and these are really important. These cross sections. So each of these is a cross section. So it's a side view of the wall, and this has a page number indicated on it, A312, and this is drawing number 3. This is A314 drawing number 3, A312 drawing number 2, and so on. That's the one thing to consider. The second thing that's important is that this arrow, see that black arrow pointing to the right? That tells you which direction you'll be faced when you get to that cross section. So we're going to be faced this way, which means to our left will be the outside of the wall, and the right will be inside. Okay, so let's keep that in mind. A312 drawing number 3. So let's find that. A312. There we go. A312. And then here's the drawing number 1, drawing number 2. And then over here we have drawing number 3. And it actually indicates it's the mechanical room. All right, so remember, we're to our left is outside and to the right is inside. So here you can see what the walls are made of, or what that wall is made of, from the bottom all the way to the top of the wall. All right, so when we're performing a heat load calculation, we need to figure out different elements, what different elements are in the wall, what the wall is made of. So let's see, we have little arrows here pointing to different parts of the wall. Okay, so let's start here. We can see first we have a polycarbonate cladding system. All that is it's this sort of like semi-opaque plastic that's really just a detail, doesn't really do much. For our purposes, there's a little bit of an R value associated with it, but not much. And then we have this aluminum rain screen subframe. So this isn't really all that important for insulation purposes. Here's a 5/16 inch fiber reinforced cement vertical. So this is basically cement board, um, and it's 5/16 inches. So we could look up the R value of that. That's the outside layer. And then we have a membrane, waterproof membrane. Not really, doesn't matter for R value. This is really important. We have 6-inch stud, metal stud framing. That is 16 on center. So this is important. So this is metal framed, 6-inch metal studs, and then has sprayed on cellulose insulation. And so this means that we have 6-inch walls with have metal studs that are 16 on center, and then we have 6 inches of spray foam insulation where there's not studs. So this is a pretty high efficiency building. So the spray foam, older buildings, you're going to see something like a fiberglass bat, but this is spray foam. This would be a closed cell foam, which you're going to get a pretty high R value, probably around R7 per inch, but that's something you would have to look up. And so that's our wall later. Now, unfortunately, we don't have what's inside here, although up here it does show half-inch plywood sheathing. And you got to be a little bit careful because this is actually the ceiling here. So this would be this is the ceiling of the mechanical room, and this is the inside of the mechanical room. And this is actually exposed. So this is an outside wall. It's just where the HVAC unit is above the mechanical room. Um, and so that shows you what, we have half-inch plywood here, and then this is your cement board. So the issue is, and this happens sometimes, is you don't actually, it doesn't tell you what's on the inside of the interior wall. Um, but you can look in other parts of the building and you'll see that there is, it's just drywall. So we'll just have to make an assumption if we can't find that for this room. What we could do is look at the interior wall of the mechanical room, and it's going to have the same material. I think this is, let's see, that's the storefront. That's the door. Yeah, I think this is actually the other side, the interior wall. And you can see here, yeah, they still don't have. This is the roof, metal framing, outside, super cement, door. Yeah, so they don't have um, the drywall, but we can look at other parts of the building to find the drywall. So at any rate, now we have a really good sense of what the wall is made of. And what we'd have to do then is look up the R value of these different components using an R value table, which will be provided with your lab. The other thing, and I just want to point this out, uh, to not forget that there's actually part of the R value calculation will be there's an air layer, and I know it sounds weird, but there actually is a little bit of an R value to the outside air layer and a little bit of an R value to the inside air layer. So don't forget those. But otherwise, you would just find the R values of each of these components, and then you would just add them up. So air layer, wall, insulation, cement board, polycarbonate, and then you just add those up, and that's your total R value for the wall. And just keep in mind that in this wall, since there is a metal stud, part of the wall, there'll be basically two R values to this wall. The one R value is the area of the wall that has the metal stud cross section, and then the other R value would be instead of a metal stud, you have 6 inches of spray foam. So those are two very different R values because metal is almost no insulating properties, whereas spray foam has very high insulating properties. So you just have to keep that in mind that there's actually, even though it sort of looks like there's one cross section, there's actually two cross sections. One with the metal stud in the middle and one with spray foam in the middle. Okay. All right. So hopefully that helps you navigate the construction drawing for purposes of a heat load calculation.